I'm setting up a MIG welder in my brother-in-law's shop, and we're putting some self-shielded flux core on it, so I thought I'd bring you along. We'll talk about the main thing that makes all the difference, and then the second main thing that makes a whole lot of difference, and then all the little things that also make a difference. Let's do it. If your self-shielded flux core has been looking like this instead of like this, there's a good chance that it's one thing. So we're going to talk about that today, but first we're going to set the machine up and talk about a few other things that can also make a pretty big difference. I'm switching over here to a 10-pound spool. It is NR211, made by Lincoln. I'm welding Lincoln wire on a Hobart machine. It's 0.35 diameter, and it's been a long time since I used this machine. I posted a video a few years ago using this machine, doing a repair on a friend's garage doors. And I might have even used this very wire, I don't really remember. But anyway, take a look at the wire here. It's old, it's been sitting out, it's really rusty. I don't really want to weld with it like this, so I'm going to strip several layers off of it and get it down to some clean looking wire before I even get started. Once I do that, I'll snip the wire and hook it in that hole on the spool to make sure it doesn't unspool on me. I'll put the retainer nut back on. And then, next thing I'm going to do is remove the contact tip so that I can strip the old wire. And I don't want it to hang up on the contact tip and bird's nest on me. By the way, it's handy to have a nice set of MIG pliers if you're doing flux core or bare wire MIG. They're made to not only clean out the nozzle and snip the wire, but they're made to grip the contact tip. So once I get the contact tip loose and out of there, I'm going to go back to the machine and I'm going to make sure I don't have a burr or a kink or anything in the wire. I'm going to pull it through the liner. But if it's got a good bend in it or a hook or a crook or something like that, it's going to make it tough to pull through. So I'm going to snip it and make sure there's no bend or burr on it. I'm going to pull it through the end until I get all that out of the gun. And then I'm going to go back and start the wire feeding up inside the liner. But first, let's take a quick look at drive rollers and talk about those just for a minute. Remember that self-shielded flux core has got flux inside the wire, so it's hollow. And if you use too much drive roll pressure, you're going to crush the wire. So the knurled groove is going to work better because you want to use lighter pressure and you want something to grip on that flux core wire without crushing it. So carefully, I'm going to get it started up in there a few inches without kinking the wire, and then I'll put tension on the wire. Very light tension. That's another thing. You want to really pay attention to how much tension you put on flux core wire because it is hollow. So you don't want to use as much tension as you would use on hard wire. So with the contact tip removed, my brother-in-law, Larry, is going to hold the trigger until the wire comes out the end for a few inches. And that's all you need right there. Contact tips are a consumable, and it's good to have several extra ones on hand, and they're sized for the wire that you're using. This is 0.35 wire. I need an 0.35 tip. I'm going to slip that contact tip right over the wire and thread it on, and I'm going to snug it down with the MIG pliers. Again, the MIG pliers have a little notch that's just made for that size of the contact tip. It's got little grip teeth on it. Makes it real convenient for that and also snipping the wire. You don't necessarily need a nozzle when you're doing flux core wire. I stopped and got this flux core nozzle. You could use the regular MIG nozzle. In fact, it's pretty useful if you want to prop with the nozzle and do tack welds. But for the sake of the video and just being able to see better, I'm going to put the flux core nozzle and it'll protect all that hardware and not get sparks on it and screw it up. So that lets me see better and lets us film better. There are several ways you can set the tension. As I mentioned earlier, you want less tension than you do on hardware. There is a little bit of leeway, a little fudge factor. You don't have to have it exactly right, but you don't want it tight enough that it crushes the wire. You don't want it loose enough where it slips. So what works for me is when I pull the trigger and then hold it with a glove hand, I want to be able to stop that wire, but I want to also have to pinch it kind of hard in order to stop it from going without making the drive roller slip. And I can just adjust it to where it does that, and that usually works out pretty well. Every welder is going to be a little different. This machine is called a 210 MVP. That stands for multi-voltage plug. So with the adapter, I can either run 115 or 230 volt. Today we're going to be going 230 volt. In the future, I'll run some 115 volt videos. Okay, here is the one thing that will make all the difference if you have it wrong. It will make your welds to look like this with all those BBs, extra spatter. This one simple change will make it a whole lot better, and here it is. On the inside of the panel of the wire feeder cabinet, it even tells me here which polarity I need to be on. DCEN for flux cord wire. Now dual shield runs on DCEP, but self-shielded needs DCEN, direct current electrode negative, and it'll make a huge difference. Taking a quick look at this machine, you can see that the negative output goes to the power block there where the MIG gun plugs in. That's electrode negative. We're good. All the main manufacturers will have a MIG settings chart on the inside of the door, and they're all pretty close. They'll get you started. So I'm going to select 1/8 inch materials, what I'm going to be welding here. I'm going to follow it down, making sure to select the right wire diameter and all the other appropriate things. And it tells me 4 and 35. Well, what the heck does that mean? That doesn't tell me what voltage or what wire feed speed, but I'm just going to trust it. I'm going to set at 4 on the voltage, which is a click setting, not an infinite setting, but that's fine, and 35 on the wire feed speed. And we're going to give that a go and see how it works. Another important thing for any wire-fed process, bare wire or flux core, is a ground. If you clamp the ground to somewhere that's got mill scale on it or paint or grease or whatever, and you intermittently lose your ground, your wire feed speed doesn't care, and you're going to think it's screwed up. The second thing that makes most of the difference, aside from the polarity, is stick out. I've seen people try to use a really long stick out. Now sometimes you have to on really large diameter wires. You have to run it out there a good inch or more. But this is 0.35 wire. It doesn't need that long of a stick out. If I use a inch or 2 long stick out, it's got a bend in the wire from the curvature. It's going to wander around out there. It's going to give me bad results. This is probably the one beginner mistake that I have seen more often than the other, is just using a really long stick out like this. Here I'm going to tighten it up quite a bit. You can see already everything is way smoother, way better, a lot more controllable. I've got about a 5/8 to 3/4 stick out on that weld. Okay, let's talk a little bit about how to hold the gun angles, push versus pull, and things like that. Fortunately, a lot of that is kind of forgiving as long as you have the stick out about like that. I checked the Lincoln spec sheet really quickly for this diameter NR211, a 1/2 to 5/8 CTWD contact tip to work distance. So we're going to be in the ballpark right here. This is the gun angle that I've found that works kind of good. Just kind of 45 in there into the root of the joint, a slight drag, keeping that stick out again to about 5/8 of an inch. Don't get carried away this way, don't get carried away the other way. There's forgiveness. Just don't get carried away with your angle. You can push, but you're going to get more spatter. Just don't get carried away with extreme angles. Unless, of course, you have to, because something's in your way, because there's exceptions to every rule. But as a rule, try to have your gun angle about like this. As far as PPE goes, make sure you're wearing gloves, long sleeve welding shirt, good quality helmet. Safety glasses and a fan even helps to blow the smoke away from your breathing zone. All right, let's take a look at this. I didn't change any settings. All the bad welds that you saw earlier were done with the exact same settings, except that this is using the correct polarity here. And of course, somewhere close to the right stick out, or CTWD. They're not exactly the same. I often refer to them as the same thing. They can be the same thing, but it's splitting hairs really. Just how much wire is sticking out there between your puddle and your contact tip is the stick out. Isn't it amazing what one little change can make? I mean, just a change in polarity makes a somewhat decent looking weld. Let's chip that off and give it a wire brushing. Take a look at it. The settings listed on the chart that I used seemed good and hot. I mean, it seemed like it was really penetrating, but taking a look at that crater and seeing how it was just really punching in there really makes me want to do some further testing on this wire and this machine, which I will do in future videos. Now, the reason that a machine can be on the wrong polarity is a machine like this will run bare wire with shielding gas as well as self-shielded flux core. And so somebody may have just had it set for bare wire, and you got to check. So here's how to swap it. I'm going to go ahead and put it on DCEP. This is how you go about swapping polarity on this machine. It takes about a couple of minutes. And once again, this is what you get when you weld on the wrong polarity using self-shielded. An awful lot of machines are sold at yard sales. People buy a machine, a cheaper machine, and they just think the machine's no good, and they sell it. And all it was the polarity needed to be switched over to DCEN. We covered a lot of stuff, but here's a really quick review. All right, the main thing, make sure that polarity's right. DCEN. Make sure to use the right size drive rollers for your wire and use the knurled groove. Set your tension lower than you would for bare wire. Low enough that you can stop it with your fingers, but you have to pinch it kind of hard. Make sure to have a really good ground, whatever that takes. Start off using the recommended settings with the MIG chart on your machine, and be careful to follow the right columns for the wire size and the wire type. Use the recommended stick out. In this case it was about 5/8 of an inch, and things should go a whole lot better for you. Stay tuned for some different thicknesses and some vertical uphill. Hey, I'd appreciate it if you go check out my store at weldmonger.com. High quality welding gear like TIG kits, tungsten, gloves, new products being added regularly. Go check out the reviews. Appreciate your support.